Okay, assignment AH6V. This is a long one. It's about nearly an hour long, this video, so be prepared. Number one, during a game they can win or lose counters. Alma, Bernice and Chloe have counters in the ratio of 4 to 5 to 6. At the end of the game, they share the same number of counters in the ratio 5 to 7 to 6. So the number of counters is the same, but the ratios between them have changed. Show that Alma has more at the end than she started with. So let's see, at the start of the game, what can we say? Alma has, let's look at the ratio. The ratios are 4 to 5 to 6, so there are 4 shares to 5 shares to 6 shares of Chloe, so altogether there are 4 plus 5 plus 6, 15 shares. The ratio is in 15 parts, if you like, and Alma has 4 of them, so she has 4 out of 15. I can use my calculator to turn that into a decimal, and I get 0.2666 and so on. So now do the same thing at the end of the game. So now the ratios are 5 to 7 to 6, so the total number of shares is 5 plus 7 plus 6, which comes to 18. So Alma has 5 shares out of 18. Which equals on the calculator 0.27777 and so on. So since 0.277 is bigger than 0.2666, which means that Alma gets a larger share of the counters at the end. So in other words, she's got more counters at the end than she started with. Question number 2. Factorize 3x squared plus 5x minus 2. So we've got 2 brackets because it's a quadratic, and 3x squared must be 3x times x, but the constant 2 can be 2 times 1 or 1 times 2, and I don't know which way round it goes. It's a matter of trying both of them and seeing which one works. So maybe I'll start by let's try putting the 2 in here in the first bracket and a 1 in the second bracket, just to see. Now in the middle term I want it to be 5x plus 5x. The only way I can get that is 3 plus there and plus there, because then you get plus 3x and plus 2x is plus 5x. But that gives me plus 2 and I want minus 2, so that answer is wrong. So now we try the other alternative. 3x in the first bracket, x in the second bracket. And instead of 2 and 1, we now put 1 and 2. Put the 2 at the end and the 1 in the first bracket. Now here, once again, we want plus 5x. So I could get that by having 3x times plus 2. 3x times plus 2 gives plus 6x, and minus 1 times x gives minus 1x. And also minus 1 times 2 gives minus 2, which is what I want. So that's the correct one. So the first attempt was wrong. And I can now move on to number 3. Here is some information about the number of books read by a group of people. One of the frequencies is missing, that one there. Midpoints are used to work out an estimate for the mean number of books. The answer is 9.5. Work out the missing frequency. So let's see. That means 16 people read 2 books, roughly 2 books, so on. I'm going to call the frequency f and the midpoint x, and I'm going to work out f times x, because 16 times 2, 32, that means those 16 people read a total of 32 books. Here, I don't know this entry, so I'll call it p. So p, the frequency of those who read 7 books. So 7 times p, 10t, 20 times 12, 240, and 10 times 17, 10 people read about 17 books each. So that's 170 books that were read. So we can add all those together to get the total number of books that were read. So I've got to take the total number of books, first of all, which I'd get by adding all the entries in that column, 240, 170, 410, 442 plus 7p. When you add all those entries, that's the total number of books, and they were shared by a number of people, or group of people, which we can get an expression for by adding all the frequencies. N, let's call it 16 plus 20 is 36, 46 plus p. Number of people. 46 plus p. Now I've written it as a fraction, 1 divided by the other, because if we take the total number of books and divide by the number of people, that gives us the mean number of books read per person. So the mean is equal to total number of books divided by the number of people. But we know what the mean is. They've told us that the mean is 9.5. So I can put that expression equal to 9.5, and now I try to solve that expression or that equation. I multiply 46 plus p times 9.5 to get 442 plus 7p on the left equals 9.5 times 46 is, on my calculator, 437, and plus 9.5 times p. Now, as a simple equation in p, I can solve it by taking 437 to the left-hand side and getting 5. Take the 7p to the right-hand side, I get 2.5p. So p equals 5 divided by 2.5, which is 2. So that means that the missing frequency there is 2, which is what we were asked for. So we better write down the conclusion that the missing frequency is 2. Question 4. There are 2 function machines, A and B. A says input, square, and then add 1 to get the output. B, subtract 3 and then square. Both machines have the same input. Work out the range of input values for which the output of A is greater than the output of B. So we'll call the input x in both cases, since it's the same. Now in A, x, first thing you have to do with x is to square it. That gives me x squared. And then you add 1. So it's going to be x squared plus 1 as the output. Second machine, B, subtract 3, so x minus 3, and then square the result. So it's going to be x minus 3 squared. And we've got to say that the output of A is greater than the output of B. So that relates machines A and machine B outputs. So x squared plus 1, the output of A, has got to be greater than the output of b, which is x minus 3 squared. I can expand the bracket on the right. X squared minus 6x plus 9. Then I can collect like terms. X squared can be subtracted from both sides. So I can say that this leads to x squared goes away from there and from there. I can take the 1 across to the, well, let's say, bring the minus 6x to the left. I get 6x greater than 9 minus 1 is 8. So x is greater than 8 over 6, or x is greater than, if you want to simplify, 4 over 3. Question 5 now. In the triangle, angle y is obtuse. We've got angle, we want to find angle y, and we've got, what have we got in this triangle? We've got the side opposite angle y, we've got angle 33, and the side which is opposite 33. So we've got angles and their opposite sides, so that tells us that perhaps we should be using the sine rule, because that involves angles and their opposite sides. Let's just try and get the whole diagram in. So we can say sine y over 15 is equal to one of the other angles, sine 33 over 9. That is using the sine rule. So I can now simplify this and get sine y equals, take the 15 to the right hand side, 15 times sine 33 divided by 9. Now you can use your calculator to get y. When you do that on the calculator, you get, you can see, I get 65.19 degrees. But be careful, whenever you have the sine, it can also be 180 minus that value, because both of those angles have the same sine. Sorry, I've written 15, that should be 19 there, 65.19. So the second one there comes to 180 minus 65.19, which is 114.81. And that is our correct answer. Not that one, that was the acute angle, and it's 114, that should be a 9. So 114.81 is the obtuse angle that we are told that y is. Number 6. Box is a cuboid with these dimensions, and they are to the nearest centimetre. Then DVD cases have dimensions like so, which are measured to the nearest millimetre. So that, let's call that width W, big W, and big H, capital H, and capital B for breadth. So I'll call this little one here little w, and little b, or little breadth, and little h. Then let's try and write down what we know about these things. The width of the big box W, measured to the nearest centimetre. 27 to the nearest centimetre Basically, that means if you had a scale that was counting just in whole numbers, centimeters, 27, 28, 26 on the left, then if something is to the nearest, it's 27. It could be anywhere from 26.5 to 27.5, anywhere in that range, 26.5 and 27.5, we would still say that it is nearest to 27. It's nearer to 27 than to 26 or to 28. So nearest to 27 can be anywhere between 27.5 on the upper bound and 26.5 on the lower bound. Similarly, we can do H and B in the same way. B, measure to the nearest centimeter. So 16 could be as much as 16.5 and going down to as small as 15.5. It could be half a centimeter either side of the value. And similarly, H is going to have a maximum of 20.5 and a minimum of 19.5. Now we do the same thing for the DVD. The box or a CD? I'll put CD anyway. So little w is now 1.6 centimeters to the nearest millimeter. This time it's millimeters, so we look at the second decimal place and say it's 1.65 centimeters and 1.55 centimeters to the left. Similarly for B, this is because 1.6 centimeters for the width is 16 millimeters. 16 millimeters is between 16.5 and 15.5. That's where it works. So little b goes from 14.15 to 14.25, and similarly little h is between 19.25 and 19.35 at the maximum end. 19.25. So now we've got to see, does the CD fit into the box? We're told there are 16 of them. They think they can fit 16 of them into the box, like 1, 2, 3, 4, like this. Little w's each one of them. So can 16 of them fit in? And to see whether this works, we've got a B there and an H there. So the B and the H are straightforward because it's a single base and a single height. So let's look at the little b. The maximum value is 14.25 and the minimum value of big B is 15.5. So easily little b maximum is less than the minimum value of the box. So that's fine, it can fit in. What about the H max is 19.35, and that is just about less than the minimum value of big H. So H max is less than big H min. And what about W's now? So we can say for little w, 16 W max, if we take 16 of the maximum values of W, little w, 16 times 1.65 on your calculator, I think it comes to 26.4, and that is just about less than the 26.5. So we can say that 16W max is less than the big W minimum. So it can just get in. So every dimension of the CD can fit into the box, so 16 CDs fit into the box. Question 7. Bag X contains 6 blue balls and 12 red balls. Bag Y, 8 blue, 16 red. Dave picks a ball at random from X and he puts it into Y. Esther now picks a ball at random from Y. Show that probability that Dave picks a blue ball is equal to the probability that Esther picks a blue ball. So, the way I would approach this is with a probability tree. The first event is Dave choosing a ball, and he can either get a blue or a red. Chance of him getting a blue one is 6 out of the total, so 6 out of 18. There's the chance that Dave will choose a blue ball, so the remaining 12 out of 18 are the chances of getting a red ball. Then we move on to the second event, which is Esther choosing a ball, and we have to do both possibilities there. So Esther, no matter what Dave has done, Esther can get a blue or a red in all cases. So going along the first branch, if Dave gets a blue ball, that blue ball goes into bag Y and becomes 9 blue balls. So there's 9 blue and 16 red, so 9 out of 25 for Esther. Okay? And how many red ones for Esther? Well, there's still 16 red ones for Esther out of the 25. If Dave chooses a red ball, then there are still 8 blue balls in bag Y, so that's 8 out of, but Dave's put another one in, so it's 25. And if Dave chooses a red ball, then there were 16 red ones, so now there will be 17 red ones in bag Y. 17 out of 25 is the probability that Esther gets a red. Show that probability that Dave picks a blue ball equals the probability that Esther picks a blue ball. Dave is easy. Probability that Dave gets a blue ball is just 6 over 18. Is 6 over 18, which is 1/3. So now Esther is a bit more complicated. Because there are 2 ways in which Esther can get a blue ball. There is this outcome here, or there's this outcome. Both of those are possible. In the first case, it means Dave put a blue ball into her bag, and then she got a blue ball. Or the other way, well, let's work out the first one first. 6/18 is a chance that Dave, along the first branch, times 9/25, the probability of the second branch, and we multiply those two together to get the probability of the outcome. Then the other way, Dave gets a red one, puts it into bag Y, so now we have to add the probability of the second outcome, which is going to be 12 over 18 times 8 over 25. So we take those. So here we get, if we cancel, that's a third. So 1 times 9 is 9 over 3 times 25 is 75. Plus 2/3 for 12/18 gives us 16 on the top and 75 on the bottom. And 9 plus 16 over 75 is 25 over 75. And that comes to 1/3. And that third is exactly the same as the probability of Dave getting a blue one. They're both 1/3. So we've done what we've asked to show, that their probabilities are the same. So maybe I should just write the conclusion. So the probability Dave gets blue is equal to the probability that Esther gets a blue, and they're both equal to 1/3. Question 8. So here the graph shows the depth of water, d centimeters at time t, when the water is running into the container. We can see these are the times from 1 to 5. The depth is going from 0 to 25. So you can see that as time goes along, then what happens? The depth starts increasing quite quickly. Then it slows down a bit. It's still increasing, but not as quickly as it was before. But then it starts increasing again. So the depth is going fast from here to here. Then in the middle, it slows down. Then it goes fast again. So what kind of container? It can't be A, because that would go at the same rate all the time. Container B, because it's wide at the bottom, it would take a long time to get started and go slowly and then speed up because it gets narrower. The bottom one is narrow at the bottom, so it goes fast and then slow. This one is narrow, so it goes fast at the bottom, slows down in the middle, and goes fast again at the top, which is exactly the same as we had on our graph. We had fast here, slow there, and fast there. So that is the one that we want. Option D. Use the graph to estimate the rate at which the depth of the water is increasing at 2 seconds. You must show you're working. So to get the rate at 2 seconds exactly, that means we want the rate here at this point. Then we've got to draw a line, a tangent, that just touches the curve at that point. I'll try and draw one approximately. That's not bad, but I think I could do probably a bit better than that. Let's see if I can adjust it a bit. You can do it with a ruler. It's a lot easier with a ruler than it is with a computer. Still not happy. I think I need to tilt it a bit more this way. Yeah, something like that. Now let's bring it down, and I think that looks good. Yeah, that looks nice. It's just touching at the point where t is 2. And so what we've got to do is to work out the rate of change at that point, which means the gradient of that red line. I've got a point there, which is 210. I've got another point, sorry about that. I've got another point at 316. So between those 2 points, I can get the gradient or the slope, and that will give me the rate of change. So we've got tangent passes through the first point was 110, and the second point was 3, I think. Let's just check. Yep, 316. So the the rate is given by the gradient of that tangent. going to be y2 minus y1, 16 minus the rise over the run. 16 minus 10 is the rise, and the run 3 minus 1, x2 minus x1. So we get 6 on the top, 2 on the bottom, giving us a gradient of 3. Maybe we should give it some units, so we should look back to the question, and the question involves d centimeters and t seconds. So it's going to be centimeters per second for the rate of change. So in question 9, Anna and Ben had a race. Here is Anna's speed time graph from the start of the race. We have the speed there, and if you go down low enough, you'll see the time axis. Go a bit lower. Time is going from 0. The velocity is 0 at the beginning. Then she gets faster up to 5 meters per second. Then runs along at 5 meters per second for quite a long time. Then starts to slow down at the end. So the distance of the race was 100 meters. Ben ran it in 25 seconds. Who won the race? You must show your working. So what we've got to do here is basically we need to work out, we need to find time that Anna takes to run 100 meters. Because then we can compare her time with Ben's, see who wins. So we've got to work out how do we get the distance of 100 meters from a speed time graph is to do with the area under the graph. The area under the graph represents the distance covered. So if that area A is the distance covered from 0 to 4, then the next part of the graph I think I'll use here. If I call that part there, I'll make it bigger, I think. Like that. Then I'll call that B. So the area B is from 4 to 7 to 21 seconds. And then the last part, the remaining part, I'll call that C. Because the graph is naturally in 3 parts. So if we can work out the area under each of those parts, we can get the distance that Anna runs. So area A, first of all, that base of that triangle is 4, and the height of it is 5 units, using the scale along the left-hand side. So the area of A is a half times the base, which is 4 times the height, which comes to 10, and the units will be meters, because it's the area under the graph represents the distance covered. Area B, you look at area B is a rectangle, and it goes from 4 to 21, which means it's 17 units long along the base, and it goes from 0 to 5, that's 5 units up. So the area of B is just a rectangle, 17 times 5. So A and B together gives us 95 meters. So Anna has run 95 meters, but she needs to run 100, same as Ben. So let's see. So we need now area C now from 20, I think I'll take it in the first second after the end of that rectangle, from 21 seconds to 22 seconds. Let's have a look at that on the diagram. From there to there. Now that is a trapezium, that shape C. Goes from 21 to 22, so it's 1 unit that way. And vertically it goes from 5 to 4.5 roughly. So how do you find the area of a trapezium? It's a half times the height times the sum of the two parallel sides, 5 plus 4.5. So that's about 4.7 meters. 4.7 meters and 9.95 meters plus 4.7 comes to 99.7 meters. Not quite 100. She hasn't quite managed 100 meters yet. We haven't done enough distance, so let's take another trapezium in the next second from 22 to 23. So it's half times 1. Now what are we going to have there? So looking at the diagram, trapezium D is 4.5 on the left, but on the right hand side its vertical height is about 4.1 there. So it's 4.1 I think I'll use there for the sum of the two parallel sides, which comes to 8.6 is 4.3 meters under the area D. So if I add 4.3 onto 99.7, I get 104 meters. Which means that in how long is that? 23 seconds total. 23 seconds. So she's covered 104 meters in 23 seconds. Ben covered only 100 meters in 25 seconds. So Anna was the winner. Question 10. In the figure, what are we told? B is the midpoint of AC and C is the midpoint of AD. OA is 2P, OD is 2Q. Find AD. So AD, the vectors, nice thing about vectors is to get from A to D you can go any way you like, so it's best to go along directions that vectors that you already know. So from A I can go up this vector to O, down that one to D. As long as I start at A and finish at D, that's the main thing. So going against the 2P, that's minus 2P, but following with the 2Q, so it's plus 2Q. And you can rearrange that if you like to put the positive part first, 2Q minus 2P. Then CD we're asked to work out. CD, well, CD is the same direction as AD, but half the length, because C was the midpoint. So CD is just a half of AD. And I know what AD is. AD is 2Q minus 2P, so a half of that will just be Q minus P. So that's CD. So now the last one, OC. From O to C, I can go from O to A and then A to C, or I could also go from O to D and then D to C. I'll go that way, I think. O to D, so OC equals OD plus DC. OD is just 2Q. Now DC, D to C goes the opposite way from CD, so it's minus CD. The vector DC is minus the vector CD, and 2Q minus, now CD, I know what CD is from the previous part, is Q minus P. Now I can get rid of the bracket carefully. 2Q minus Q is going to be q, and then minus q, p is plus p. Question 11 says, an approximate solution to an equation is found in this iterative process. That thing there, that formula. x1 equals 0. Work out the values of x2 and x3. So iterative means it goes around and around. Think of the function as something like a machine. You start with xn, and out of the other end comes xn plus 1, and then you use that value of xn plus 1 to put back into the beginning of the machine. So you can go round and round as many times as you like, getting a more and more accurate solution. Okay, so let's see what we can do here. We want to ask us to work out x2. x2 equals, using the formula, a quarter, brackets, 1 minus xn. Now xn, if x2, then n is going to be 1. If n plus 1 is 2, n is 1, so x1 cubed. So that gives us a quarter, brackets, x1 we are told is 0, so 0 cubed, which is just 0. So 1 minus 0 is 1, times a quarter is a quarter, or 0.25. We can now use this x2 to work out x3, because x3 equals a quarter, brackets, 1 minus, now I use x2 inside the bracket, x2 cubed, which will give me a quarter, and then brackets 1 minus 0.25 for x2, but we've got to cube that and then subtract it from 1. Do that all on the calculator, and according to my calculator I get 0.246, what else? 0.9375. Next part says work out the solution to 5 decimal places. So you have to keep on going around the iteration until you get 2 values which are close to each other within 5 decimal places. So x4 is a quarter, 1 minus x3 cubed. And if I put that in, that value for x3 into my calculator, I get 0.246274,009. 2 and the 4 and the 6 are the same, but the 4th decimal place is different. So let's look at x5. Is a quarter, 1 minus x4 cubed. Now we're going to use that value that we've just worked out for x4 in the bracket, and if you do that, then you'll find that you get, according to my calculator anyway, I get 0.246265,815. So here we can see 1, 2, 3, 4 decimal places are agreeing, but the 5th one is different. x6 is equal to a quarter, 1 minus x5 cubed. Take that value of x5, put it into the bracket, and work out on your calculator. You get 0.246266,188. 1, 2, 3, 4, 5, but the 6th one is changing. So I think to be absolutely sure, I like to try and get If I'm trying to get 5 decimal places, finally, I try to work to about 7 in the intermediate stage. So here, for x7 equals, and I put x6 in there, and it comes to 2, 4, 6, 2, 6, what's next? 6, 1, 7, 1. Now here we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 decimal places agreeing. So I think that's good enough for rounding off to 5. So the solution to 5 decimal places is 0.2462. And then the 5th place, 6, is followed by 6 in the 7th position, or in the next position. 6 is bigger than 5, so that 6 is rounded up to 7. So it's 0.24627 to 5 decimal places. Question 12. The curve with equation x squared minus 3x plus 2 is reflected in the y-axis. Circle the equation of the reflected curve. So imagine axes, and you've got a point there reflecting in the y-axis to give a point on the left. There's the y-axis, so you've got any value x on the right is turned into negative x on the left-hand side. So all you have to do is, when you're looking at your equation, I'm going to replace x with negative x everywhere, so that x squared becomes negative x squared, minus 3x, and minus 3 times minus x, and then plus 2. In other words, if I simplify that, I get y equals x squared, because negative x times negative x, x squared, minus 3 times minus x is plus 3x, plus 2. So I get this equation, and looking at my choices or options, I get that that is the one which is given. Question 13. Diagram shows a line joining OP, gradient is a half, and the length is square root of 500. Work out the coordinates of the point P. Maybe I'll drop a perpendicular here. I could call this maybe A. I'll call that one B. Then we're told the gradient of the line is a half. So the rise over the run is equal to a half. So I can write A over B equals a half. Or if you want to rearrange that, 2A equals B. So B is 2A. So instead of B on the diagram, I could replace that B by 2A. Okay. So now, look at that triangle. It's a right angle triangle, so I can use Pythagoras. And I can solve it for A. I can say A squared plus 2A squared equals the hypotenuse squared. Square root of 500 squared is 500. So A squared plus 2A squared is 4A squared, so it's 5A squared altogether, equals 500. So A squared equals 100. So A is 10. And what do I know about B? Well, we know that B is 2A. So that's just going to be 20. So the coordinates of P are just 20 and 10. 20, 10.